Benefits of curtain wall systems for retail construction. Welcome to Building Knowledge 101. In this video, we will look into the performance, durability, and aesthetic benefits of curtain wall systems for retail projects with taller elevations. Some retail designs want to have taller, larger elevations and want more glass on the exterior. When you get to elevations around 13 to 14 feet in height, now we're going to jump to a curtain wall system. So storefronts limited structurally in height, but curtain wall systems can pick up where storefront leaves off. So when you have taller free-spanned elevations, we're going to start looking at a curtain wall system. Since curtain wall is tended to span past the floor lines, it needs to have the capacity to be spliced. Multi-floor elevations require multiple extrusions that are spliced together one on top of the other to continue the elevation up. Tall elevations can't be dead loaded all the way down to the slab, so the system will require dead load anchors to transfer the weight of the elevation back to the structure behind it. In some cases, the mullions might span past a floor line without the need of dead loading back to the floor line, but they still have an attachment. It's called a wind load anchor. Wind load anchor prevents the mullions from deflecting inward under wind load, but allows the slab to deflect up and down behind it without interfering with the curtain wall. In these pictures, you can see examples of curtain wall to the exterior of the structure spanning past the floor lines. So at each floor line, there's spandrel glass. So spandrel glass conceals the anchors, the slab edge, and the plintum behind it. But you can see the glass continues on up. So there's either going to be a wind load or a dead load at each of those floor lines. And at some point, you'll have a splice where mullions are stacked one on top of the other. I mentioned earlier that as you get higher on a building, your wind loads increase. So if you look at this picture, we've got in the lower floors, punched openings or horizontal ribbons that are not full height. They're shorter spans and they're set within the structure of the building. So on the second, third, or fourth floor, those could be storefront. But on this project, you can see how high it is, and the same elevation and same application continues all the way up. So as you move higher on this building, your wind load increases, quickly overpowering a storefront system. So even though these are small elevations, small spans set within the structure, we're going to have to use a curtain wall on this project because of the height of the building and the increased wind load as we move up it. Retail facilities want people walking by to see the displays on the inside. They want people to be able to look in without disruption and see all display of merchandise on the inside. So larger lights of glass are desired to provide good views to the interior. Large lights can exceed the structural capacity of a storefront system. Here you can see in this example, the verticals are not very tall. They're running slab to slab within the structure of the building. It's a low-rise application. So those are the characteristics of a storefront system. But also notice the width of some of these lights of glass. They're quite wide. So now we need to be concerned about dead load capability of a system. Because of the width of these large lights of glass, we're having to go to a curtain wall in this elevation because a storefront system can't carry that much weight. So dead load is driving us here to a curtain wall system. Curtain wall systems drain water light by light. Storefront systems drain water down the verticals, collect in the subsill, and then weep out. But tall elevations like here, you couldn't drain water all the way down the verticals. It would quickly overpower the system. There'd be too much water at the base, and it would probably leak to the interior. So to handle water on large elevations such as this one, curtain wall weeps water at each light of glass. Each light of glass weeps water independently. Here you see examples looking up at the underside of covers, and you can see holes. These are weep holes. So each light of glass is going to have two weep holes in the cover and the pressure plate. So any water that gets into the system won't pass the horizontal, stop on the horizontal, and then drain out at each light of glass. So curtain walls, you can continue to stack up higher and higher because each light of glass performs independently. That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.